So this is again a problem from diesel cycle. So an engine working on diesel cycle has a diameter, that is bore, is equal to 150 mm and the stroke is 200 mm. Clearance volume is 10% of the swept volume. Determine the compression ratio and air standard efficiency of the engine if the cutoff takes place at 6% of the stroke. So first of all, let us write the given data. So we have bore. Let us represent it using a small letter d, that is equal to 150 mm. Then stroke length we will represent by letter L, that will be equal to 200 mm. Then it is given that clearance volume is 10% of the swept volume. So clearance volume we will represent it as Vc. Vc is 10% of the swept volume. We will represent swept volume by Vs into 10 by 100. So 10% of swept volume, that swept volume, that is 0.1 Vs. That is equal to Vc, and determine the compression ratio and air standard efficiency of the engine if the cutoff takes place. So we want to calculate these two values, that is compression ratio and air standard efficiency if the cutoff takes place at 6% of the swept volume. So that also we will write it here. Cutoff. So fuel is cut off, or heat addition is cut off at 6% of the swept volume Vs. So it is better to draw a diagram, so we will understand things a little bit better. So consider a piston cylinder system. So suppose this is our cylinder. Now we have a piston. So we know that cylinder bore is a diameter, that is 150 mm, and the cylinder has a stroke length of 200 mm. That means this piston is in the BDC now. When it reaches TDC, that TDC position I represent here. When the piston reaches TDC, so the distance travelled from BDC to TDC, that is the stroke length. So this distance is 200 mm. So we can also find that that volume displaced by the piston will be the swept volume, that is Vs, and this volume is the clearance volume, that is Vc. Now after the compression, the piston will go back, while the heat addition process, in diesel cycle we have a constant pressure heat addition, so the piston will be slightly moving outward and heat is added to the system. So let this be the position of the piston when the heat addition is cut off. So this is the point where the cutoff happens. Cutoff at 6% of the step to volume, that is this volume is 6% of step to volume, that is 0.06 Vs. So now we can calculate the compression ratio. So to calculate the compression ratio compression ratio R is equal to V1 divided by V2. Here V1 is this entire volume, so that will be equal to Vs plus Vc, and V2 is this volume, that is clearance volume, that is Vc. So V2 is Vc. So Vs we have Vs plus Vc is 0.1 Vs divided by 0.1 Vs. That makes our compression ratio 11. So if you divide it, you can see that the compression ratio is equal to 11. So this part, that is compression ratio, is found out. Now we have to calculate the air standard efficiency. So in order to calculate the air standard efficiency, if you recall the expression for efficiency of a diesel cycle, we have in that expression we have, I'll write the expression here. So efficiency of a diesel cycle is 1 minus 1 by R raised to gamma minus 1 by gamma rho raised to gamma minus 1 divided by rho minus 1. So here R is the compression ratio, that is already we have found out, and gamma is the ratio of Cp and Cv, that is 1.4, we know that. Then rho is the cutoff ratio. So in order to calculate the efficiency, we have to find out the cutoff ratio also. So cutoff ratio, here the cutoff happens at this point, at this position. Then the piston gradually moves from top dead center to bottom dead center, while this piston is moving in this direction. At this point the cutoff happens, that is fuel heat addition is stopped at this point. So that is a cutoff point. So cutoff, so we can find out the cutoff ratio, that is rho is equal to, rho is actually V2 divided by V3, sorry V3 by V2, V3 divided by V2. V3 is this volume, so that will be equal to Vc plus 0.06 Vs divided by V2 is again Vc, so Vc is again 0.1 Vs that is equal to 1.6. In fact, you don't have to calculate here the diameter and the stalk length are given, but we don't need that data. In fact, we can directly from these two expressions Vs gets cancelled and we can directly obtain the compression ratio and cutoff ratio. So this data is actually redundant, we don't have to use that. So our expression for the efficiency eta is equal to 1 minus, so I'll take this. And here we have R is equal to 11 and rho is equal to 1.6 and gamma is equal to 1.4. So if you substitute that, eta is equal to 1 minus 1 divided by 11 raised to gamma minus 1 is 0.4 times 1 by 1.4, 1.6 raised to 1.4 minus 1 divided by 1.6 minus 1. So we'll obtain it as 0.5753. So our efficiency eta is equal to 57.53%. So we got compression ratio as well as the thermal efficiency. So that's about the problem. So thank you.